Hi everyone. In today's video, I'm going to talk about one of the fundamental programming aspects of Java, and that is how to use primitive types. Java has 8 primitive types that come with it in the language, and those are byte, short, int, long, float, double, Boolean, and char. What we're going to talk about in this video is cases in which you would use all 8 of those types, what you might actually see in day-to-day code, and then why you would choose one type over the other in particular situations. Are you new to programming or new to Java? Then welcome. This video is intended for both very new programmers as well as experienced programmers looking for just a quick review on how these data types are used. Today I'm going to be working in the IntelliJ IDE. So I'm going to go ahead and create a new project. I'm going to call it primitives. I'm going to put it in the code directory and I'm going to hit add sample code. Now, if you're looking for information on what all of this is, what this main.java is, the main method, and this print line function, go ahead and check out one of my previous videos above and I'll go through the details of how you make your very first Java program, which explains how all of this works. So I'm going to go ahead and delete the print line function, and the first type we're going to talk about is byte. The byte data type is a byte of memory. You can think of it like that. And what I mean by that is it contains 1 byte's worth of information, where a byte is 8 bits. And a bit is either a 0 or a 1. It's binary. It's what the computer uses to store information. So when we're talking about 8 different independent 0s and 1s, each 0 and 1, that's 2 different values it can have. And if there are 8 independent values that you can have there, that would be 2 to the 8, which is 256 values. So when we talk about Java, all primitive types other than 1 are considered signed. So what that means is rather than having a range of up to 256, the actual range of the type is from half that on the negative side up until half that on the positive side, but you have to subtract 1 because you have to count 0. So while you might think that the range of values would be 0 to 255, that's for an unsigned byte. For a signed byte, you're going to go -2 to the 7th up until 2 to the 7th minus 1, which is going to be about -128 to 127. Or in the general form, it's going to be -2 to the 7th until 2 to the 7th minus 1. So values I could have for here, an instance, I could have 100. I could have -100. I could have -128. But note that if I do 128, now IntelliJ is telling me, hey, there's something wrong here. So if I hover over this, this is telling me that I have a required type of byte because I'm indicating a byte variable right here, but that I'm trying to assign it to an integer. That's basically telling us that we're trying to assign a variable outside of the range of values that it can accept. So we'll go ahead and we'll set that to 1. You'll see bytes get used periodically in code when you need to be efficient with memory, but they aren't super often used. You'll see them from time to time when you're looking at code. Now, the next one is going to be short. Let's set this to 3. A short contains double the memory that a byte does. So instead of 1 byte, a short has 2 bytes, which would be 16 bits. So think about what the ranges on a signed short might be. On a byte, we had 2 to the 8 possibilities. So we went from -2 to the 7th up until 2 to the 7th minus 1. So for shorts, we're going to go 2 to the 15th, which if you pull up a calculator, 2 to the 15th is 32,768. Now, you might see shorts used periodically, but most often folks don't use shorts because they actually go straight to integer, and that's what I'll go to here next. But before I go to that, just to demonstrate some of the value ranges of a short. If I were to try to assign 1,000 to a byte, that wouldn't work, but I can assign a value of 1,000 to a short. I can also assign 10,000 to a short. This is going to be a lot of zeros. I want to make this a little easier to read. One of the nice features since Java Standard Edition 7 is you can add underscores to delimit integer literals. It doesn't actually change the value of the integer, it's just used to make it more readable. So I'm at 10,000 right now. If I were to make this 100,000, now it no longer can interpret that into a short. That would be an integer. So I'm going to go ahead and put that back to 10,000. So now the next data type that would be after a short would be integer. Integers are 4 bytes worth of data. So a byte was 1 byte, a short is 2 bytes, an integer is 4 bytes, so 32 bits. So the range of an integer is going to be 2 to the 31 on both ends. And I don't have that number memorized, but it's a little over 2 billion, basically. So let's actually find out what it is. Java has a nice way of having constants for us, which indicate the valid range of certain primitive types. So I am going to see what integer.max value is. Looks like it is 2,147,483,647, which means on the min value side, which there's also a constant for that, you would throw a negative sign in front of there, and then you would add, or you subtract 1 to get to 648. So integers are what you're going to see a lot of the time in production Java code when it comes to storing what you would think of as a whole number. The reason for that is because more often than not, a number doesn't need to exceed 2 billion or be lower than negative 2 billion. Now, there are a few cases where you might need that. So for instance, let's say that you have a program like YouTube, which is tracking the number of views of a video. There are some videos out there that might have over 2 billion views. If you're using a signed integer like you would here, that wouldn't work because you'd start having what's called overflow, where you're having the value of the variable go over what the variable can handle. So there's another data type for that, and that is long. The long data type contains 8 bytes of information. So that is 2 to the 64 different options, which would mean that within the range of values, since this is also a signed type, we're going to go 2 to the 63. Now, if I pull up a calculator here, 2 to the 63 is a humongous number. Let's see, that's 3, 6, 9, 12, 15. Okay, so this is 9 quintillion as the upper range, and then the lower range is going to be 9 quintillion. So there are very few instances where a long is not going to have everything you need for it. Generally speaking, you're going to get more than enough if you were to ever have a long data type. One thing that I brushed over really quick is overflow. So what an overflow is when you're exceeding the value of what the data type is intended to carry, and then you are expecting something to work a certain way. So what I'm going to show you right here is what happens when overflow exists on a byte data type. Right there. So what you can see is we set variable 1 equal to the max value of a byte, which is 127. var1++, what this is doing is this is adding 1 onto the existing value of var1, and then we're printing out the value. When we print out the value, we see that we rolled back to negative 128. So the important point here is you want to look at what is required to get the job done, but you have real drawbacks if you make the data too small. you can run into overflow conditions, and now let's say your code wasn't ready to handle negative 128 in this case, and you have an error case, production code is broken, oh no. The other case though you have to think about is, well, I don't want to use bytes because they could overflow. Why don't I just always use the long data type, because I'm never going to exceed 9 quintillion, right? Well, sure, you may never exceed 9 quintillion, but your problem's going to be a long data type is the equivalent of 8 bytes. So if you need to start having a whole bunch of variables, you're using 8 times the memory if you otherwise could have used bytes and then just done a little more range checking. So that's kind of the trade-off you'll hear computer programmers talk about, where you might want to talk about efficiency of your code versus memory usage or things like that. That's where that really kind of comes together. You need to be careful about the data types you're going to select, in that you don't want overflow, but you also don't want to use excessive memory. So oftentimes when you're looking at others' code, what that really turns into is 9 times out of 10, everyone just uses integers. And then you need to almost ask yourself, if an integer's not used, why didn't they use an integer? What's the reason for it? Did they specifically think about the range checking that might need to happen on it? So another thing that's special about the long data type is Java assumes that all integer literals you're giving it are integers. Okay, sure. Why does that matter? Well, I'll show you. Let's assign this long to 10 billion. So 10 million looks good. Uh-oh, what's going on? If I hover over this, this is telling me integer number too large. Okay, but I'm assigning it to long. What's the problem? Well, since Java assumes that all integer literals are integer types, we need to explicitly tell Java that we want this to be a long. And how we do that is we add a L on the end of the literal to indicate this is a long. The language also allows you to do a lowercase l. My problem with lowercase l's is sometimes, depending on the font or how quickly you're reading the code, you might not look at that carefully and you might see that as a 1. So that's why I like to use uppercase L. But that's how you denote a long compared to a regular integer type. Okay, so what else can we do with integer literals? Let's say we've been talking in base 10 this whole time. I don't want to talk in base 10 anymore. I want to talk in hexadecimal, base 16. So to do that, you prepend a 0x, and then you add on the hexadecimal characters after it. So this is an integer because it's 1, 2, 3, 4 bytes of data. A byte would be 2 hexadecimal characters. If I wanted to add a 5th byte, I just add the long modifier and then we're good to go again. Kind of like base 10, I can add the underscores to delimit the bytes to again make it clear what I'm trying to set here. Now, let's say that I don't want to do base 10 and I also don't want to do base 16. Let's say that I'm dealing with bits and bytes. So I can actually do binary. So I'm going to prepend this integer literal with 0b for binary. And then I'm going to type in 4 bits, which translates to decimal 11. So I'm going to delete this line and then we'll double check that that is decimal 11. There we have it, decimal 11. All right, so we've spent a good amount of time explaining how we represent integer literals with byte, short, long, and int. What else can we do? We can also represent decimal numbers. The way we do that is with either the float or the double type. So we'll talk about float first. So float is an IEEE 754 defined floating point number, is what that is. Float contains 4 bytes, so that's 32 bits. And the way in which those 32 bits encode a decimal is actually a pretty complicated process. That's why there's that IEEE 754. There's a specification that documents that, and that could be a whole other video topic. But point being, Let's say that you want to write out some decimal numbers. You could do that with floats. Now you'll notice here we're getting a problem where IntelliJ doesn't like this. Okay. We're telling IntelliJ that we want to have a float, yet it's saying that we're providing a double. Well, why is that? Well, just like how integer literals are assumed to be integer types, decimals in Java are assumed to be doubles. So we have to explicitly tell Java that we want this to be a float. So we can either do that with a lowercase f or an uppercase f. I prefer an uppercase f because it's consistent with uppercase L for longs, but you don't have as much of the readability concern with lowercase f as you do with lowercase l with those numbers. So what you get out of a float is a range of precision. You might get anywhere from 4 to 8 decimal points, something like that, depending on the number of significant figures you're talking about. So if we're talking about 0.12345 versus 98765.12345, you might have difficulty encoding one of those or the other in a float alone, which is where the double type comes in. That's where you've got doubles. So now this is a double precision number. I'm going to get rid of the F there because I don't need to indicate this is a float anymore. Double precision numbers have double the precision. They have double the bits. So instead of 4 bytes or 32 bits, now we have 8 bytes or 64 bits. So a double and a long actually use the same amount of memory, but they're encoding very different things. A long is holding very large numbers, while a double is holding high precision of a range of numbers. And what I mean by a range of numbers is another thing you can do is you can use what's called scientific notation. So if anyone remembers from their chemistry class, you might remember this number, 6.02 times 10 to the 23rd. That's a mole of atoms. Well, in Java, to indicate scientific notation, you just throw that little E right there. Alternatively, just like how you can capitalize an F for float or an L for long, you can also capitalize that. One other thing I should mention is if you're ever in a situation where you need to explicitly say that the data type you're looking at is a double, you can throw a D on there and Java will interpret your decimal number as a double. That's very rarely used though, because the default decimal literal for Java is double, so you don't often need to indicate that you're actually assigning this to a double because it's assumed as that already. Now that we've talked about integers and floating point numbers, let's talk about Booleans. A Boolean can contain only 2 values, true or false. The Boolean type is one of the most used types in the Java language because logic is the heart of code. And one of the simplest ways you can think of as logic is this statement true, or is this statement true, or is this statement false? And the easiest way to interpret that is with a Boolean expression, and the Boolean data type returns and holds and manipulates the value of that type of expression. So what's an example of a Boolean expression? Well, we've got a short here named var2 with a value of 10,000. I'm going to go ahead and add parentheses. Now, does var2 equal 10,000? Yeah, it does. So we just stored the value of asking, does this equal? And by the way, this double equals here. This means, does it equal? Well, a single equal sign entails assignment. This is, I want you to assign this variable to this value. Whereas double equals says, this is a logical check. Does it equal this? And to clean up the output here, I'm going to go ahead and comment that out. I'll go ahead and run this code. And you'll see, yes, var2 is equal to 10,000. Now let's say I want to change it to 10,001. You'll see that this returns false. All right, and that value is false. So Boolean is one of the really important primitive types to understand because it gets used all over the place within various programs. But the last data type is the character data type. Characters are 16-bit unsigned Unicode encoding, depending on the specific encoding you're talking about. One thing you might hear is different pronunciations of this right here. I call it char because char is short for character, but you'll also have people call it char or car. And everybody has their preferences. Some people get really heated about which one's right. For me, I just stick with the easiest thing that comes to me, which is what does it actually mean and what's it short for? And in this case, that's why I call it char. Just like I call int integer rather than like int or something like that, it's integer. So that's why I call this char. Anyway, so a char is a 2-byte encoded value of a character. What I mean by character is an uppercase A, a lowercase a, an underscore, a comma, any of those sorts of things are characters. But what a character is not is something like this, because this is actually 2 different characters. And you can see it says there are too many characters in character literal, so I'm going to go ahead and undo that. And now what we have here is this character literal. The other thing we did is we encased this in single quotes. That's important because double quotes in Java refer to strings. So if I were to attempt to set that to a string, you'll see that it doesn't like that either. Similar reasons as before. The required type is char, but we're providing a string. So we'll go ahead and undo that. So now we're back to character again. So character types encode characters. Strings encode a string of characters. Oftentimes you won't see character used all that often. You might use it from time to time, but most of the time people just use strings. So out of all this, which of the primitive types are most important? Well, in my opinion, you'll see byte used from time to time in something like a memory efficient array, which I can talk about in a future video, but you don't see them super often. Shorts you hardly ever see in code. Usually there's a good reason someone would have a short, so if you're reviewing someone's code and you see a short, you could ask them, why. Integer you'll see most often, followed by long. You'll see float every once in a while, but typically when somebody's looking for decimal precision, they're going to look for double. Boolean is used all over in code, and then characters not used super often. So out of all of these, the most important ones to take away are going to be int, double, and Boolean. All right, guys, hope you enjoyed that quick crash course in primitive types in Java. We talked about all 8 primitive types, including those that hold integer literals, character literals, Booleans, and decimal literals. I hope you enjoyed this video. If you did and you haven't subscribed, please consider subscribing to my channel. Like the video if you enjoyed it, and feel free to drop a comment if you have any additional thoughts on things I should cover, or if this video didn't hit the mark, or if you thought it hit it spot on. I'd love to hear from you. Thanks again for coming and watching this video, and we'll see you next time.